Good morning, students. Welcome to the DMM1 lecture of Unit 3. We are in the revision class discussing about the subject of DMM1. So, we have already completed Unit 6, Unit 5, and Unit 4. Today, we will discuss about Unit 3, the concept of design of riveted joints and welded joints. Right? Yes. So, if you see the syllabus of this Unit 3, that is riveted and welded joints, we will discuss about the introduction of rivets, what is the meaning of riveted joint, what are the application of riveted joints, what are the design features of joints, and also their initial stresses induced in the parts, and also the introduction of welding joints, the types of joints, the applications of welded joints, and their eccentric loading and stresses. And also we'll see the bolted joints, their design, and the design of joints under eccentric loading, the locking devices, both uniform strength and different seals. So we have a revision class in this session that we will not go in deep in this unit. So I will briefly explain the topics and we will discuss about few problems so that we can rewind the unit 3, right? So apart from 2 or 3 problems, balance problems, you have to practice on yourself, right? So we will go the first session of lecture 9, the repeated joints. Okay, see, already have drawn the figures in machine drawing. This is the part 1, this is the part 2, this is the part 3, this is the part 4, right? So these are the 4 plates where you are riveted with 1, 2, this is a 3 rivet, this is a 4 rivet, this is a 5 rivet, this is a 6 rivet. So these are the 6 rivets which are placed and riveted on these 4 plates, right? So we will discuss in deeper. So here in the engineering application, we have 2 or 3 sheets or 4 plates which are joined together, which carry the load in such a way that the joint is loaded. So we can do by welded joints or we can do by riveted joints. So the welded joints are the permanent joints, whereas bolt and nut assembly rivet joints are semi-permanent joints. Many times such joints are required to leak proof so that the gas contained inside is not allowed to move outside. A rivet joint is easily conceived between the 2 plates overlapping at the edges. Make holes through the thickness of the both, passing the stem of the rivet through the holes and creating the head at the end of the stem of the other side. A number of rivets may pass through the rows of holes. Got it? So here, whenever you are making a shape with the sheets, so we have to make end to end, edge to edge overlapping, and have to make holes through which the rivet has to be inserted, which is carefully uniformly distributed along the edges of the plate. With such joint having created between the 2 plates, they cannot be pulled apart. If the force at each of the free edges is applied for pulling the plate, the tensile stresses in the plate along the row of the rivet hole and the shearing stresses in the rivets will create a resistance force. Such joints have been used in the structures, boilers, and ships. So what this point is saying, so whenever you are having a sheet, whenever the other sheet is overlapped like this, right? So whenever you kept some rivet joints and whenever you are pulling with the longitudinal forces applying in this direction, right? Applying in this direction, that is a tensile forces, tensile stresses in the plate along the row of the rivet hole and shearing stresses in the rivets will create the resistance force. This can be seen in which applications? The steel structures, the boilers and the ships. Once after completing this riveted joints and bolted joints and welded joints, so what you will come to know, so you can describe the type of riveted joint, what type of joint is done. Then you can explain how to calculate the strength of the riveted joints, right? So in the machine drawing already I've drawn the figures, the front view, the top view of the riveted joints and welded joints, right? So where the rivet, for example, if you see the rivet is here, other rivet is here, right? Other rivet is here. So this is a zigzag proportion, right? So you can see the distance and as well as the stress involved in this rivets. Next, third one, explain how many different ways the rivet joints can fail. Next, describe the types of welded joints. Describe the types of welded joints. What are the various types of welded joints you are using for the application? Next, explain the manner of loading the welded joint. Can define the failure modes of welded joint and also describe how to design a welded joint. So these are the things you can study once the unit is completed. Now, if you see the rivets, the mechanical joints are fasteners. So we can call joint or fasteners. The mechanical joints or fasteners are used for making connections between different elements of machine or a structure. A machine or structure is made up of large number of parts, and they need to be joined suitably for the machine to operate in good condition. In manufacturing industries, the joining of two or more components is necessary for assembly purpose. Joining makes the production more reliable. Joining makes the production more reliable, efficient, and profitable. In fact, joining can be defined as one of the manufacturing processes by which two or more metal sheets or solid components can be assembled together. Simply, we can call the joining is defined as a mating of two or more solid components and can be assembled together, right? Next, coming to the types of joints. Mechanical joints are broadly classified into two categories. One is permanent joint, other one is a temporary joint. So in between you are having semi-permanent joint also. Okay. Coming to the permanent joints, the joints which cannot be easily disassembled. So whatever the joint we have done, later it should not get detached. That is, it should not be easily disassembled without damaging the connecting elements. So whatever the plates మీరు తీసుకున్నా కానీ whatever the sheet you have took, wood or metal or whatever glass, it should not physically damage the shape, and also it should not get disturbed the parent components. In that way we should get dismantled. Next, different types of permanent joints are: first one is welded joints, brazed joints, and solder joints, adhesive joints, riveted joints, and interference joints. These are the various types of permanent type of joint applications. Coming to the temporary or detachable joints, these are the joints which can be easily disassembled without damaging the connecting elements. Whatever you are doing, assembly chesina, disassembly chesina, it should not disturb the physical appearance of the element. Next, the different types of detachable joints are thread joints, pin joints, thread ante bolt and nut assembly, pin joints, quarter joints, and key joints. These are the various types of temporary or detachable type of joints. Got it? So if you get any theory question, you can write this concept. Next, coming to the flow chart, a mechanical joint is of two types: the permanent joint and a temporary joint. You can write in this way also: welded joints, brazed and sold. These are the two welding applications. This is adhesive means with a gum or some sort of resin component. Next, it is a riveted joints, interference fit, threaded joints, pins, quarters, keyways. So this can be shown in in this way. Next, coming to the what is the difference between permanent joint and a temporary joint. does not allow dismantling of assembled components without rupturing them. Temporary joints allow easy dismantling. So అంటే dismantling means విడదీయడం. Dismantling of assembled components without breaking them. Permanent joints are usually leak proof. అంటే whenever you are having any gas or liquid in a container, so leak అనేది జరగదు. That is a permanent joint. Temporary joints are not necessarily leak proof. The strength of the permanent joint is very high. Usually joint strength is same that of the components. The strength of the temporary joint is comparatively less. A permanent joints cannot be disassembled easily. Often, destructive testing is carried out which damages the assembled structures. Here, no destructive testing is required for us inspection of joints. Next one. Repair and replacement are difficult and costlier. So ఈ పర్మనెంట్ జాయింట్లో వాట్ ఇస్ ద థింగ్ రిపేర్ చేయడం కానీ రిప్లేస్మెంట్ చేయడం కానీ ఈజ్ వెరీ డిఫికల్ట్ అండ్ ఇట్ ఈస్ అ కాస్ట్లీ ప్రాసెస్. హియర్ వీ కెన్ డూ ఈజీలీ. Next, permanent joints are suitable for such applications where separation is usually not desired in the service life. Okay, so coming to the temporary joint, these are suitable where frequent separation of assembled components is required. Next one. Examples are welded, bracing, riveting, and adhesive, fasteners, press fit, quarter joints, and knuckle joints. So, if you get a question in a part A or part B, difference between permanent and temporary, you can write this matter. Next, coming to the main concept of rivet and riveting. What's the meaning of a rivet? So, if you see this 2D figure, it is a rivet. It is the head of the rivet, it is the shank portion, there is a body portion, there is a tail portion. A rivet is a short cylindrical rod having a head and a tapered tail. So tapered means a slant. Okay, the main body of the rivet is called a shank. So we are calling this part as a shank. This part as a shank portion. Okay, this part as a shank portion. According to the IS Indian standard specifications, the heads are of various types. The riveted heads are general purpose or specified by IS standards below 12 mm diameter, right? From 12 mm to 48 mm diameter. So according to this standard, it should be below 12 mm. According to this standard, should be 12 mm to 48 mm diameter. These are used for boiler works or specified by this standard. To get dimensions of this head, you can go with the machine data handbook. Okay, so in this rivet heads, for example, boilers మీరు చూడలేదనుకుందాం in the industry. So if you see any our RTC buses, normal Palle Velugu or normal express deluxe buses, you can see on the bus exterior, బస్ ఎక్కేటప్పుడు చూస్తే మీరు గ్లాస్ మన విండోస్ కింద అన్ని రివిట్స్ వేసి ఉంటాయి, స్మాల్ స్మాల్ రివిట్స్, రైట్? యూ కెన్ సీ దోస్ రివిట్స్. సో దీస్ ఆర్ నథింగ్ బట్ రివిటెడ్ జాయింట్. ఓకే, సో మనకి బస్ అనేది ఎలా స్ట్రక్చర్ చేస్తారు, ఫ్రేమింగ్ లేయర్స్తో చేస్తారు, లేయర్ ఆఫ్ షీట్స్. సో ద డిఫరెంట్ లేయర్స్ ఆఫ్ షీట్, దిస్ అ riveted section. Okay, this is a riveted section. Okay, like this. Next, riveting is an operation. Riveting is an operation whereby two plates are joined with the help of a rivet. Adequate mechanical force is applied to make a joint strong and leak proof, right? So smooth holes are drilled first and punched and reamed in the two plates to be get joined as the rivet is inserted. Shouldn't this is a die, this is a backing up bar. So these are the two workpieces. This is a workpiece 1, this is a workpiece 2. So this is a backup bar where it gives additional support. So this is a die where it will shut it. So ఇలా ఇన్సర్ట్ చేసి దీన్ని బ్యాక్ సపోర్ట్ చేసిన తర్వాత వీఆర్ pressing this one. So whenever you are pressing this one, this shape is converted to this shape. So finally this portion is a riveted portion. This portion is a, అంటే మీకు ఎలా ఉంటుంది, ఇలా కనిపిస్తుంది, రైట్? దిస్ పోర్షన్ అంటే మీకు ఎలా ఉంటుంది, ఇలా వచ్చి ఇలా వచ్చి ఇలా వచ్చి ఐ షేప్లో not, right? Depending upon the whether the rivet is initially heated or not, the riveting operation can be of two types. So whenever you are pressing with this top die, so initially we are having two types. One is normal room temperature setting, other one is a heating. So in the first type, cold riveting is done at ambient temperature or room temperature. Hot riveting is done initially heated before applying the force. So దీన్ని మనము heat చేసి then we can apply the force, thereby it can be converted into this shape. After riveting is done, the joint is heat treated by quenching and tempering. So in your metallurgy and material science subject, you have heard about the heat treatment process. So after riveting is done, what the joint is to be done? The joint is heat treated by two heat treatment process. One is quenching process, other one is a tempering process. In order to ensure what leak proofness of the joint, and additional operation like caulking is done. Caulking, I will say, in the later slides. So this is the main thing happening in the riveting section. Coming to the types of joints, so these are classified based upon the three categories. One is application. So what type of application we are doing? Okay, so where we are applying. Next, according to the position of the plates connected. Second one is according to the position of the plates connected. Third one, according to the arrangement of rivets. According to the arrangement of rivets. According to the purpose, the riveted joints are first one. So first one తీసుకున్నప్పుడు when you get a theoretical question in the exam, ఇవి రాయండి. First, according to the purpose, according to the position, according to the arrangement of rivets. According to the purpose, strong joints, tight joints, strong tight joints. So strong joints low, the strength is only the criteria. In the tight joints, the joints are provided the strength as well as a leak proof. Okay, joint and reservoirs, containers, tanks, ఇవన్నీ ఎగ్జాంపుల్స్ అనమాట టైట్ జాయింట్స్కి. నెక్స్ట్ స్ట్రాంగ్ టైట్ జాయింట్స్, దీస్ ఆర్ ద జాయింట్స్ అప్లైడ్ ఇన్ బాయిలర్స్ అండ్ ప్రెషర్ వెసల్స్ వేర్ యూ ఆర్ డూయింగ్ హై అండ్ ఆపరేషన్స్, దట్ ఈస్ in heat exchangers. Industries lo heat exchangers lo we can use this type of strong tight joints in order to have a strength as well as leak proofness. Coming to the types of rivet joints, the riveted joints are mainly of two types. First one is a lap joint, second one is a butt joint. So e types of joints we already chadukunaru. See here how the lap joint is done. So this is a plate 1, plate 2. సో లోపల మనకి ఎలా కనిపిస్తుంది, లోపల మనకి దాని షాంక్ పోర్షన్ ఇలా ఉంటుంది. ఓకే, షాంక్ పోర్షన్ ఇస్ ఇన్ దిస్ వే. సో ఇనీషియల్గా ఇది టేపర్డ్గా ఉంది, పైనుంచి మనము విత్ డైతో ప్రెస్ చేసినప్పుడు ఇలా అయిపోతుంది. ఇది ఆల్రెడీ బ్యాకప్ మనకి ఒక సేమ్ షేప్లో వీఆర్ హ్యావింగ్ సమ్ మెటీరియల్. నెక్స్ట్ కమింగ్ టు ద బట్ జాయింట్. So what is the butt joint here? So the butt joint is in this direction. See here. So this is a plate 1, this is a plate 2, this is a plate 3. So you could both, you can see the lap joint as well as butt joint. So here it is lap joint, here it is butt joint, right? So this is a covering plate, these are rivets. So these are the butt joint diagram. Next, the butt joints are of the following types. The butt joints are of following types. First one is single strap butt joint. Second one is a double strap butt joints. So here also you are having some of the types in this butt joint. Single strap and double strap. ఇవన్నీ already we have done in your machine drawing. Machine drawing లో మీరు already figures వేశారు, right? So here in the single strap, the edges of the main plates but against each other, only one cover plate is placed on the one side of the main plate and riveted together. In addition to the above, following of the types of riveted joints depends upon the number of rows of the rivets. First one is single riveted joint, second one is a double riveted joint. From the figure you can see which one is single riveted, other which one is a double rivet. So a single riveted joints law where there is a single row of rivets in a lap joint as shown in the figure, and there is a single of rivets on each side in the butt as well as the shown in the figure. Single riveted lap joint, లో see the blue color portion and ఇది ఒక plate, right? ఇది plate 1, this one is a plate 2, right? So the plate 1 on it, the plate 2 is placed over it, and here you are getting a series 1, the rivet 1, the rivet 2 and the rivet 3. సో మనం ఫ్రంట్ వ్యూ చూసినప్పుడు ఇలా కనిపిస్తుంది, రైట్? సో యాక్చువల్గా ఇట్లా పైకి ఇట్లా రావాలి, బట్ ఫర్ యువర్ weaving, so it is like this. The distance between the rivet to rivet, that is a P. Okay, the single riveted lap joint. Next, double riveted lap joint, chain riveting antam దీన్ని. So here you are having the other nomenclature PB. So chain rivets 1, 2, 3, 4 like this. So this is a double riveted lap joint. Next, coming to the double riveted zigzag joint. Zigzag ante enti? See here. So here manaki parallel ga undi, right? సో ప్రపోర్షనేట్గా ఉంది, బట్ హియర్ ఇట్ ఈస్ నాట్ ప్రపోర్షనేట్. ఇది కొంచెం యాంగిల్లో ఉంది, ఇది కొంచెం యాంగిల్లో పెట్టాడు. ఇవన్నీ నార్మల్గానే ఉంటుంది, రైట్? సో హియర్ ఇట్ ఈస్ ఇన్ ద ట్రయాంగిల్ ఫామ్. ఓకే, ఇట్ ఈస్ అ జిగ్జాగ్ మేనర్. ఇవన్నీ ఫిగర్స్ మీరు ఆల్రెడీ వేశారు. సో వాట్ ఇస్ ద మీనింగ్ ఆఫ్ దిస్ ఎక్స్ఎక్స్ వైవై? సో అంటే ఇక్కడ కట్ చేస్తే మీకు ఇలా కనిపిస్తుంది. సో దట్ ఈస్ ద one of the method in this drawing concept. Similarly, we are having other type of triple riveted joints also. Okay, so if you see this one, it is a triple riveted lap joint. Indulo chain riveting undi, zigzag riveting. Triple means simply plate sheet perugutundi. There is a one row, there is a second row, there is a third row. Okay, now see ikkade idantha vachi welding anamata. Okay, this one is a welding. Next, దీనిలో చూస్తే row 1, row 2 and row 3. బట్ ఏంటి ఇక్కడ జిగ్జాగ్ మేనర్లో ఉంది, జిగ్జాగ్ మేనర్. ఓకే, నెక్స్ట్ సింగిల్ రివిటెడ్ డబుల్ స్ట్రాప్ బట్ జాయింట్. సో ఇప్పటి వరకు మనం చెప్పుకునేది ఏంటి? దిస్ ఇస్ అ ల్యాప్ జాయింట్. ల్యాప్ జాయింట్లో ఓన్లీ ప్లేట్ 1, ప్లేట్ 2 ఈజ్ ఇనఫ్. ఓకేనా? దిస్ అ ప్లేట్ 1, దిస్ అ ప్లేట్ 2. బట్ కమింగ్ టు ద బట్ జాయింట్కి మనకి ప్లేట్ 1 ఉంటుంది, ప్లేట్ 2 ఉంటుంది, ప్లేట్ 3 ఉంటుంది, ప్లేట్ 4 ఉంటుంది. We are having 4 plates. Plate 1, plate 2, plate 3, plate and 4. So manaki thickness is T1, thickness is T, thickness is T2. Okay na? Now see here. So the cross section cheste ila chupistaru. So ee figures kuda meer already machine drawing lo vesaru. Okay, next coming to a triple riveted double strap unequal butt joint. Unequal and it's just like a zigzag joint. Okay, see here again you are having plate 1, plate 2, plate 3 and 4 plates. See the arrangement, how they have arranged. Zigzag manner lo unequal shapes lo. See, got it? These are the figures of butt joint. The butt joints. Next, this is double riveted double strap equal butt joints. Just ide denne triple ga chesaru. See here, same plate 1, plate 2, plate 3, plate 4. So it is a equally seriously arranged. Here zigzag manner, same zigzag manner. Okay, next. So the double riveted double strap unequal butt joint with a zigzag riveting. See, only the thing is the arrangement, the placing of rivets are changed and the length of the plates are also changed. 2 is a 3 is a 4. Next, the terms which are used in the riveted joints. ఇందాక మనం చెప్పుకున్నాం కదా, first parameter is a pitch P. This is a distance between the two centers of the consecutive rivets in a single row. For example, ఇదొక జాయింట్, సారీ ఇదొక రివిట్ అనుకుందాం, సేమ్ డయామీటర్స్. సో ఈ సెంటర్ నుంచి ఈ సెంటర్ వరకు, ఓకే, ఫ్రమ్ హియర్ టు హియర్ from here to here. This is nothing but pitch P. Just student here is a pitch P. The distance between two consecutive rivets. Ilaga. This is wrong. Only series lo. Next, back pitch PB. We are calling them as a BP. This is the shortest distance between the two successive rows in a multiple riveted joint. See here, BP eక్కడ వస్తుంది? BP. This one, right? Next, diagonal pitch. Actually, PB ఉండాలి. B ఉండాలి. Okay, not this one. Diagonal pitch. The distance between the centers of rivets in adjacent rows of zigzag riveted joint. So PD. Okay, diagonal pitch PD. So this is a PB, that is shortest distance between the rows. Next, this one is a PD. See here. Zigzag లో ఉన్నప్పుడు, the diagonal గా ఉన్నప్పుడు ఈ డిస్టెన్స్ నుంచి ఈ డిస్టెన్స్ కి యూఆర్ కాలింగ్ దెమ్ యాజ్ ఎ PD. Next, margin or marginal pitch. This is the distance between the center of rivet hole to the nearest edge of the plate, usually represented as M. So these are the four types of terms which are used in the riveted joints. Next, see the parameters. Correct గా మనం చెప్పుకున్న four things. So the pitch ఈ సెంటర్ నుంచి ఈ సెంటర్ కి, ఓకే, the pitch. నెక్స్ట్, ఈ సెంటర్ నుంచి ఈ రో లో ఉన్న సెంటర్ కి is a PB. Okay, what is the PB here? Back pitch. ఇక్కడ నుంచి ఇక్కడికి, లేదంటే ఇక్కడ, we are calling them as a PD. Next, from here to the edge of the plate, that is a M. M is a margin or marginal pitch. ఇందాక మనం చెప్పుకున్న అప్లికేషన్ లో కాల్కింగ్ అంటే కాల్కింగ్ ప్రాసెస్ ఇస్ ఎంప్లాయిడ్ టు మేక్ ది జాయింట్స్ లీక్ ప్రూఫ్ or fluid tight in a steam boiler. In order to make the joints leak proof or fluid tight in the pressure vessels like steam boilers, right? Heat exchangers, air receivers, tanks, etc. A process is known as caulking is employed. అంటే మనం చేసిన రివిటెడ్ జాయింట్స్ ని లీక్ ప్రూఫ్ గా fluid tight resistant material గా చేయడానికి we are using a process called caulking. Here, a narrow blunt tool called caulking tool about 5 mm thickness and 38 mm breadth is used, right? So read this one. So చూడండి. So the caulking process అంటే ఇలా జరుగుతుంది. So here they will keep a caulking tool like this, right? This is a caulked rivet and they will press it. So ఇక్కడ ఒక setting, ఇక్కడ ఒక setting చేసి it will press it and make the sheet airtight, right? So the B is caulked. So B is caulked. The head of the rivets is shown in the figure C are also turned down with the caulking tool to make the joint steam tight. A great care is taken to prevent the injury to the plate below the tool. Next one is the fullering operation. After caulking, the second thing is the fullering. The more satisfactory way of making the joint staunch is known as fullering, which has largely superseded caulking. Here, a fullerting tool with a thickness at the end of the equal of the plate is used in such a way that the greatest pressure due to the blows occur near the joint, giving a clean finish with less risk of damaging the plate. So once the caulking is done, next operation is a fullering operation. So in this fullering operation, ఏం చేస్తారు? Whatever the thickness of the sheet you are taking, the thickness of the tool also you are taking, and you are having with a pressurized blows. So once you are having this pressurized blows like an angle, this will become some sort of adjustment and become the airtight. That is nothing but fullering operation. Next, the next main concept is failures of the riveted joints. What are the main failures of riveted joints? In this failures, we will discuss about step by step. Tearing of the plate at an edge. చూడండి ఎలా tear అవుతుందో, right? Tearing of the plate at an edge, tearing of the plate across the rows of the rivet. అంటే edge లో, అంటే ఎక్కడైతే రివిట్ ఉందో ఆ రివిట్ కి దగ్గరలో ఎడ్జ్ లో సెంటర్ కి టియర్ అవడం. అదర్ వన్ ఈజ్ సెంటర్ లో టియర్ అవడం. See here the black color portion is a rivets. Okay, see the cross section will be still out. So there's a plate 1, there's a plate 2. Now this is the diameter of the rivet, this is a margin of the rivet. So a margin దగ్గర మాత్రమే we are getting this tearing operation. Okay. A joint may fail due to the tearing of the plate at the edge as shown in the figure. This can be avoided by keeping the margin m is equals to ఎంతలో పెట్టుకోవాలి tearing, it can be avoid చేయడానికి the margin should be 1.5 d. అర్థమైందా? రెండు షీట్స్ మీరు వెల్డింగ్ కానీ వాట్ ఎవర్ జాయిన్ చేస్తున్నప్పుడు సో we should not go extremely edge దగ్గర చేయకూడదు. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ సీ యువర్ టేబుల్స్ ఆల్సో యువర్ క్లాస్ రూమ్ టేబుల్స్ చెక్కతో తయారు చేసినవి ఏమన్నా ఉంటే సో ద నైలింగ్ ఆఫ్ ద హ్యామరింగ్ విత్ నెయిల్ ఎడ్జెస్లో చేస్తే ఏం జరుగుతుంది? టీరింగ్ జరుగుతుంది. దట్స్ వై దే విల్ నాట్ కీప్ అట్ ద ఎడ్జ్, దే విల్ మెయింటైన్ సమ్ డిస్టెన్స్, దట్ ఈస్ ద స్పెసిఫికేషన్ 1.5 d, the diameter of the bolt, where d is the diameter of the riveted hole. ఓకేనా? సో ఈ హోల్ ఎంత డయామీటర్ ఉంటుందో ఆ డయామీటర్ ఇంటూ 1.5 డిస్టెన్స్ తీసుకొని ఇక్కడ నుంచి ఇక్కడ డిస్టెన్స్ తీసుకొని దెన్ యూ ఆర్ మేకింగ్ a rivet so that we can avoid this tearing operation. Okay, next, tearing of the plate across rows of the rivets. This one, this is across, చూసారా black color అంటే ఆ rows across the rivets. So here, due to the tensile stresses in the main plates, what happens? The tearing of the plates across the rivets takes place. This can be considered only one pitch length of the plate. Since every rivet is responsible for the much length of the plate only, the resistance offered by the plate against the tearing is known as tearing resistance or tearing strength or tearing value of the plate. So for this we'll consider P is equal to pitch of the rivets, T is equal to diameter of the riveted hole, T is equal to thickness of the plate, sigma T is equals to permissible tensile strength of the plate. Now taking the area, A is equals to tearing area of the pitch per length. Pitch length is equals to P minus D into D. Now the tearing resistance is equals to PT. PT is equals to area AT into sigma T. That is P minus D into T into sigma T. Where the tearing resistance is PT is greater than the applied force P, then the type of failure will not occur. So this is a formula for this tearing of the plate across the rows of the rivet. Next, coming to the shearing of the rivets. The plates which are connected by the rivets exert tensile stresses on the rivets, and the rivets are usable to resist the stress. This is known as shearing of the rivets. So whenever you are applying the force, tensile forces pressure in this direction opposite to the two plates, what happens? Obviously shearing of the thing takes place. Student, mismatching here, mismatching occurred or not. So this is nothing but shearing of the rivets. It may be noted that the rivets are in a single shear in the lap joint and a single covered butt joint. So this can be applied only for some applications. Okay, but the rivets are in a double shear in a double covered butt joint. The resistance offered by the rivet to be sheared off is known as shearing resistance. Okay, let's atugani whenever it is getting, so the single lap is a double lap. The shearing occurs in this direction. Shearing of the rivet hole double cover joint. Double cover load number 1, this is a 2, this is a 3, this is a 4. Now let us consider D is the diameter of the rivet hole, tau is equal to say permissible shear stress, and N is equals to number of rivets per length. Now taking the area for the single shear, area is equal to pi d square, that is equal to 2 into pi by 4. When it is a double shear జరుగుతున్నప్పుడు 2 into pi by 4 d square. When according to Indian standard boiler regulations, double shear low, we have to take 1.875 into pi by 4 d square. Therefore, shearing resistance or pull required to shear off the rivet per pitch length, single shear low, is a thing. P is equals to N into pi by 4 d square into tau. Theoretically, is equals to N into 2 into pi by 4 d square into tau. So these things we have to apply in the formulas. Now taking is equals to N into, where N is equal to number of rivets. With this, we can reduce the type of failure, okay, by taking this constant n into 1.8 into pi by 4 t square into tau. Now, the fourth one is crushing of the plates or rivets. Crushing of the plate. So, whenever the stress, whenever the longitudinal, whenever the applied stress is more on the plate, then automatically what happens that the plate will become crushed at the center portion. The failure of the rivet in such manner is known as bearing failure. The area which resists this action is projected area and the whole of the rivet on the diameter of the plane. The resistance offered by the rivet to be crushed is known as crushing resistance or crushing strength or a bearing value of the rivet. Now T is equal to diameter of the rivet hole, T is equal to thickness of the plate, sigma C is equal to safe permissible crushing strength, N is equals to number of rivets. We know that the area per rivet AC area is equals to D into T, that is equal to N into D into T. Therefore, the crushing resistance PC is equals to N into D into T into sigma C. So this is a pitch length and the type of the failure. See here how it has been misaligned. So hole ekkadundi misaligned ekkada mismatch right. Next, coming to the even these are the failures. So if you get a question, describe the theories of failures అన్నప్పుడు you have to write this first one is a just figure వేయకపోయినా పర్లేదు, write the point tearing of the plate at an edge. దానికి ఇంత తీసుకుంటే we can reduce the failure and రాయాలి. Tearing of the plate at the edge, tearing of the plate at across the row of the rivets, write the formula. Shearing of the rivets, write the concept formula. Fourth one is crushing of the plates. These are the four methods of failure in the riveted joints and rail. Next, coming to the strength of the riveted joint. PT, PS, and PC are the pulls required to the tear of the plate, shearing of the plate, tearing of the plate, shearing of the plate, crushing of the rivet. In the joint is continuous as in the case of boiler, the strength is calculated per pitch length. But if the joint is small, the strength is calculated the whole length of the plate. Okay, now next coming to the efficiency of the joint. The efficiency of the riveted joint is defined as the ratio of the strength of the rivet joint to the strength of the unriveted or a solid plate. So with this, the already discussed the strength. Let least of the PT, PS, and PC, the strength of the unriveted or solid plate per pitch P is equals to P into T into sigma T, P into T into sigma T. Therefore, the efficiency of the riveted joint, efficiency efficiency is equals to least of PT, PS, and PC divided by P into T into sigma T, where P is equals to pitch of the rivets, T is equal to thickness of the plate, sigma T is equal to permissible tensile strength of the plate material. Got it? This is the efficiency. So efficiency formula is efficiency is the strength of the riveted joint. Now we'll see how to calculation of this process. Calculation of the whole diameter of the pitch. So making the shearing as well as the crushing, right? Equally, that is areas pi by 4 t square ti is equal to dt into tau c. Therefore, d is equals to